Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Domain 3.0 of the CompTIA A+ Core 1 exam focuses entirely on hardware. It covers the physical components found inside and outside of desktops, laptops, and mobile devices. This includes the installation, configuration, and identification of parts, as well as the ability to compare devices based on specifications and use cases. For technicians, this domain bridges theoretical knowledge with hands-on ability, providing the skills required to assemble, upgrade, troubleshoot, and maintain computing equipment. Success in this domain is critical, as hardware issues are among the most common real-world support tasks. The hardware domain is divided into several key categories that will be addressed in detail throughout future episodes. These include internal components like storage drives, motherboards, memory modules, power supplies, and processors. External devices such as keyboards, printers, and monitors are also covered. Additionally, this domain includes cable types, video output standards, expansion card interfaces, and cooling mechanisms. Each of these topics may be tested on the A+ exam through both direct questions and performance-based scenarios requiring identification and implementation. Component compatibility is one of the most important aspects of hardware installation. Every part must be matched based on form factor, power requirements, and interface type. A motherboard that supports DDR4 RAM cannot use DDR3, and an ATX power supply may not fit in a mini ITX case. Incorrect pairings can lead to boot failures, overheating, or even permanent hardware damage. The A+ exam often tests whether you can identify a configuration that will function properly based on component specifications and intended use. Motherboards act as the foundation of any computing system, providing both structure and connectivity. They house the CPU, RAM slots, and expansion card interfaces, and include built-in ports for USB, video, and audio. The motherboard chipset governs communication between components and supports features like overclocking, virtualization, and multi-GPU setups. The motherboard must also physically fit inside the system case and be compatible with the processor and power supply. Understanding its layout and features is critical for building or upgrading systems. Power supplies convert alternating current from a wall outlet into the direct current voltages required by internal components. They are rated in watts, with common units ranging from 400 W to over 1000 W, depending on the system's requirements. Modular power supplies allow cables to be added or removed as needed, helping with cable management and airflow. The power supply must include connectors for the motherboard, CPU, graphics card, and any drives. Choosing an efficient power supply also reduces heat and power consumption. Storage technologies are central to system performance and data management. Traditional hard disk drives, HDDs, offer large capacities at low cost, but rely on spinning platters and moving parts, making them slower and more prone to failure. Solid-state drives, SSDs, use flash memory for faster access speeds, improved durability, and lower power usage. Hybrid drives combine elements of both. Storage interfaces include SATA for both HDDs and SSDs, as well as M.2 and NVMe for high-speed SSDs. These differences affect boot times, application load speeds, and overall system responsiveness. Random access memory, or RAM, temporarily stores data and instructions needed by the processor. RAM types include DDR3, DDR4, and DDR5, each offering different speeds and voltage requirements. Desktop RAM typically uses DIMM form factors, while laptops use SODIMMs. In servers, ECC, error-correcting code, and buffered RAM help prevent data corruption. RAM must match the motherboard's supported type and be installed in the correct slot configuration to enable dual-channel or higher performance modes. RAM upgrades are among the easiest and most effective ways to improve system speed. Thermal management ensures that hardware components do not overheat and degrade prematurely. Common cooling solutions include air cooling using fans and heat sinks, and liquid cooling using pumps and radiators. Thermal paste or thermal pads improve conductivity between the processor and its cooler. Proper cooling maintains performance and prevents thermal shutdowns. BIOS or UEFI firmware settings may allow control of fan curves and temperature thresholds, helping to balance noise levels with cooling effectiveness in different usage environments. Peripheral connections such as HDMI, DisplayPort, VGA, USB, and Thunderbolt are critical for connecting devices like monitors, external drives, and audio systems. Technicians must understand which interface is compatible with a given peripheral and what resolution or data rate it supports. For example, HDMI and DisplayPort can both carry audio and high-definition video, while VGA is analog-only and largely obsolete. Graphics cards often include multiple output types to accommodate different displays, and knowing which to use is a frequent exam scenario. Internal connectors and expansion slots on the motherboard are essential for connecting storage, power, and peripheral components. PCI Express, or PCIe, slots are used for high-speed expansion cards, such as graphics cards, sound cards, or NVMe adapters. Storage devices may use SATA ports for traditional drives, or M.2 slots for compact, high-speed SSDs. Power headers connect the power supply to the motherboard and other components. Technicians must identify and correctly use these connectors to ensure stable operation, proper power delivery, and system longevity. Form factors determine the physical dimensions and layout of computing devices, impacting component compatibility and upgrade potential. Common desktop form factors include ATX, Micro ATX, and Mini ITX, each with a specific size and expansion slot count. Laptops and all-in-one systems often use proprietary form factors that limit hardware replacement or upgrades. Understanding form factors is essential for selecting replacement parts and ensuring that cases, power supplies, and cooling systems will fit properly and perform as expected. Input and output devices play an essential role in user interaction. Input devices include keyboards, mice, scanners, biometric readers, and webcams. These devices connect through various ports such as USB, PS/2, or Bluetooth. Some peripherals, especially those used for accessibility or specialized input, may require custom drivers or configuration. On the A+ exam, candidates may be asked to identify devices by port type, function, or configuration step, particularly when troubleshooting recognition or connectivity issues. Printers are a major hardware category included in Domain 3.0. The A+ exam covers laser, inkjet, thermal, and impact printers. Each has unique operational principles, consumables, maintenance requirements, and print quality characteristics. Laser printers, for example, use toner and fuser assemblies, while inkjets rely on liquid ink and replaceable cartridges. Technicians are expected to understand installation, driver configuration, network sharing, and basic troubleshooting procedures for all printer types, which will be explored in future hardware episodes. BIOS and UEFI firmware serve as the foundational layer of system configuration. These firmware interfaces allow technicians to enable or disable components, set boot device order, monitor temperatures, and apply overclocking settings. UEFI, which is newer, supports graphical interfaces, mouse input, secure boot, and large drive support. Firmware updates can resolve compatibility problems, fix bugs, or add new features. On the exam and in the field, knowing how to access and navigate BIOS or UEFI settings is vital for hardware-level troubleshooting. Removable and portable storage devices such as USB flash drives, SD cards, and external hard drives provide quick and easy options for backups, file transfers, and recovery operations. These devices are plug-and-play compatible and often require no drivers. However, data security is a concern. Encryption, write protection, and physical access control are recommended practices when handling sensitive data. Knowing how to configure and secure portable storage is a skill that translates directly into both exam performance and workplace responsibility. Internal storage interfaces have evolved to support faster speeds and smaller form factors. SATA remains common for HDDs and SATA-based SSDs due to its wide compatibility and ease of use. M.2 interfaces, which support both SATA and NVMe protocols, are increasingly found in modern systems. NVMe, which operates over PCIe, delivers significantly faster performance than SATA. Technicians must identify which M.2 slots support which protocols and be able to choose the appropriate drive type for performance and compatibility needs. Hardware troubleshooting is a major theme in this domain. Candidates must be able to diagnose and resolve issues such as no post, no display, overheating, or random shutdowns. Tools may include post-test cards, multimeters, thermal scanners, and loopback plugs. Scenario-based questions often describe symptoms and require candidates to select the most likely cause or best troubleshooting step. A systematic approach checking power, connections, components, and BIOS settings is key to solving hardware-related problems efficiently. Safety and electrostatic discharge, or ESD. Precautions are non-negotiable when working with sensitive electronics. ESD can silently destroy components, leading to erratic behavior or immediate failure. Technicians should always use anti-static wrist straps, grounded mats, and properly handle components by their edges. Avoiding carpeted work areas, keeping humidity within acceptable ranges, and grounding yourself before handling parts are all good habits. Safety questions may appear on the exam, particularly in scenarios involving component replacement or system assembly. In summary, Domain 3.0 hardware spans every physical aspect of computing, from core components like CPUs and RAM to peripherals, power supplies, and cooling systems. This domain teaches candidates how to select compatible parts, install hardware safely, and resolve a wide range of common issues. It builds the foundation for every other area of technical support. The ability to diagnose a failed boot, identify a misconfigured BIOS setting, or replace a faulty PSU are critical real-world skills that every A+ technician must master. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.